Hi class. This lecture here continues our lecture series talking about solving trigonometric equations. By now moving into our third lecture. And here's what we're going to do. We're going to talk about how you solve trigonometric equations, quadratic in form, and solving them by factoring. Okay, so we've worked out a lot of examples so far. So let me show you this one here. All right, so this will be our example number 11 in this series. All right, so let's solve this. Let's look at 2 times sine squared of x minus sine of x minus 1 equals 0. And let's just solve these on 0 to 2 pi. We've been doing a lot of general stuff, but we'll just look at 0 to 2 pi. All right, so let me rewrite this so you can just see it a little bit easier. This is 2 times sine of x squared minus sine of x minus 1 is equal to 0. And so it kind of looks like a quadratic equation. Like if I let n, just any variable, n be equal to sine of x, this is what we would have. We'd have 2 times n squared minus n minus 1 is equal to 0. And it's like, how, if this was just an algebra problem, how would you solve this? You would factor this. And this would very, very easily, hopefully you can see it, this would factor into 2 times n plus 1 times n minus 1 is equal to 0. But like, I didn't ask you to solve for n, right? I asked you to solve for sine of x. So let me just plug back in sine of x for n. So I have 2 times sine of x plus 1 times sine of x minus 1 is equal to 0. And look, how would you solve this? Well, you have something times something equals 0 here. So just use the zero multiplication property. So you'd have 2 times sine of x plus 1 is equal to 0. Or you have sine of x minus 1 is equal to 0. So look, what would you do next, right? So basically what you would do is you just get sine of x by itself. So hopefully you can see that sine of x is equal to minus 1/2, or here sine of x is equal to 1. And so all you're going to do is now just solve these independently. Okay, so where is sine equal to negative 1/2? Right here and right here. So the solutions over here are 7 pi over 6 and 11 pi over 6. And then, next thing you'd say is, well, when does sine equal 1? Well, that would be right here at pi over 2. So we've got our solutions here. Okay, and you could put them in order. I'm just going to leave them like this, but you could see, what the heck, I'll put them in order for us. You got x is equal to pi over 2, 7 pi over 6, or 11 pi over 6. And that's it. So all you did was, you recognize that I got a squared term, and I tried to factor it there. All right, let's do another one here. This one's fun. This one's interesting. Okay. Let's solve cosine squared x plus 2 cosine of x minus 3 is equal to 0. So again, if it helps to see it, just do what I did before. Let's let n be equal to cosine of x. So then this becomes n squared plus 2n minus 3 is equal to 0. And then, what would this factor as, right? This would factor as n plus 3 times n minus 1 is equal to 0. Okay, so now plug back in for cosine, okay? So now you're going to solve cosine of x plus 3 times cosine of x minus 1 is equal to 0. Right, so you're looking for two solutions here, right? So you can either have cosine of x plus 3 is equal to 0, which is weird, and I'll talk about that. Or cosine of x minus 1 is equal to 0. Oh, and I'm sorry, let's solve this on 0 to 2 pi. Sorry about that. So look, going back here, let me get the cosine by itself. So cosine of x would be, what the heck? Look at the unit circle. Is there anywhere where cosine of x is equal to minus 3? No. So you can't solve this, okay? There's no solution here. And that's okay. That just means this part of the equation doesn't matter. There's no solution to it. So now just look, where does cosine of x equal 1? Well, that's just at 0 right here. All right. So don't necessarily worry or stress, right, when, if you solve this by factoring here and you get something like cosine of x is equal to minus 3, it just means, hey, there's no solution to that part of the equation right here. Let me scoot over and try the next one. All right, let's do 2 more. Let's try solving this one. Let's solve 4 cosine squared of x minus 1 is equal to 0. And let's do this on 0 to 2 pi. All right. Interesting. So, like, maybe, you could recognize this 2 ways. One, you could recognize this as the difference of 2 squares and factor that way. But suppose you didn't recognize that, okay? And let's just get the cosine by itself. Okay, so I'm going to add the 1 over. Let me divide by 4. And so look, I have cosine squared of x. So how do you undo a square? You're going to take the square root, and that's okay to do. All right? But now remember, when you take the square root to solve, okay, you get 2 solutions. You get a plus or a minus. So you get cosine of x is equal to, well, the square root of 1 is 1. Square root of 4 is 2. Plus or minus 1/2. So that's important. Do not forget the plus minus, okay? So when taking a square root to solve. Do not forget that. Okay, so look, now you're just going to say, okay, when does cosine of x either equal to positive 1/2 or negative 1/2? So that's why you need both that. So it could be pi over 3. It could be 2 pi over 3. It could be pi over 4 or 5 pi over 3. All right? So x could be pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. Got all those solutions there. All right, let's do one last one. That'll be fun, be interesting. Okay, it'll be something different. We've been working with all problems that are just sine, cosine, and we've done a couple tangents one. But we haven't done a secant or a cosecant problem. All right, so let's do one of those. All right, so let's solve cosecant squared of x minus 2 is equal to 0. All right, and let's solve on 0 to 2 pi. Okay. Can't actually be 0, right? Because you'll see why in a second, but I'm just putting it that way. All right, so here's what I'm gonna do. I don't know, right? What and I don't have the unit circle for cosecant. How am I gonna solve this? So let me write this as, remember your trig identity. This is 1 over sine squared of x minus 2 is equal to 0. Okay, so just use the trig identity here. Look, now let me add the 2 over. 1 over sine squared x is equal to 2. Cross multiply. Okay, so you get sine squared of x times 2. So you get 2 sine squared of x is equal to 1. Let me divide the 2 over. Now look. I got sine squared. How do I get rid of the sine squared? Or how do I get rid of the squared? You take the square root. So I have sine of x is equal to plus or minus the square root of 1/2, which is plus or minus the square root of 1 over the square root of 2. Or when you rationalize the denominator, it's the square root of 2 over 2. So look, you're just going to look and say, all right, when does sine equal either square root of 2 over 2 or negative square root of 2 over 2? That's right here. That's right here. That's right here. And that's right here. So look what you got. You got x can be equal to pi over 4, 3 pi over 4, 5 pi over 4, or finally 7 pi over 4. So again, even if you see something like secant or cosecant for some of these type of problems, just just write it in terms of sine or cosine and see what you can do from here. All right, so factor if you can. All right, factor if you can. If you can't factor, right? If you can't factor, then try using this square root to solve and see what you get right from there. All right, class, as always, you'll get a chance to practice this, and if you have any questions, let me know.